All right. Good afternoon, everybody. Did a little practice run on that sand battery idea. I didn't invest a lot of money in this, y'all, and that's already been a point where it failed. These elements are nichrome wire, the piece that's inside. They're only good for, maybe 1,000 C, somewhere like that, 1,800 degrees. The very first picture that I had, it jumped well up into the 12 real quick, is what I'm trying to get at. Degree range, which is about what it was supposed to have been for the resistance at 120. I used some brass fillet rod and stainless steel hardware to put it together to break the thermal bridge, but not, add too much resistance. I used the silicone. It's fiberglass insulation with silicone to make the electrical conduit. So nothing shorted out, but long and short of it, the little nichrome wire failed. I'm betting it could be something different. I'll have to dig it out tomorrow and figure it out. I'm using the Ugly Iron Man, the top of it, where it holds sand, is to do this test, is what I'm trying to get at. I didn't use nothing more than like brass fillet rod, and I cut some ferrules out of the copper, crimped them down, that kind of deal. But the wire was cold. It was not hot in any way, and it was pulling about 1,200 watt. I could read on the meter on the solar. Everything was wrapped in the shrink tape, and that's that marine one where it has the goo on the outside. Down inside where it's hot, there was only this here. Where it comes up out of the sand, it was wrapped. I'm going to take you over there and look. I think it was like 120 something on the surface. If you dig down at all, it gets up to about 150. And I mean like a half an inch dig down. It's just the surface tension that had it down. There was no controller on this, and that was probably the reason the nichrome wire died. You can get a PID. Oh, Jesus. Now, help me out here. I can't remember what the acronym stands for. It's just a controller for electric. And it's going to oscillate, it's going to waver the amount once it gets closer to the temperature. Now, are there elements that you can buy? This was like, I think $6 or something like that, $7. Like I said, I didn't have any money in this little project, but I wanted to see how long it would last. I mean, that's what you got to know. And so I just, if I could handle the power, if I could handle, everything, and I just, like tossed it at it, and wired it direct is what I'm trying to get at. And it handled it for about 4 hours. I was on the phone with a friend of mine, and during the whole thing, and it handled it well, increased in temperature fine. It did everything, but like I said, I think the sand finally absorbed enough temperature that the nichrome wire failed. They do make different elements. Melodium is the name of one that comes to mind. Ceramic, it's a ceramic type element. I already contacted a supplier. Matter of fact, is when I figured this one failed so quick. But are there ways around it? Well, yeah, you could probably have like a multiple the controller, multi PID controller, with multiple thermocouplers going into the deal. And as one gets so high, it cuts it off, and then it allows the other one to ramp up and back and forth, and where you can hold it at a lower temperature. Like I said, we were getting to the temperature where this wire was going to fail regardless. It's not going to last at full throttle forever. Like a Melodium one, that's a whole different deal. That you're talking like 1,800 C, way hot. I mean, way good for what the application would be. You'd use that like in a kiln or some application like that, industrial application. But if I can get a cheap enough element from these people, I'll buy one, even if it's less than $200. But do I want to go any higher than that? No, not this year. I've spent enough on solar and all that. I might get like a multiple PID controller. Use two is what I'm trying to get at. But put these at different levels and use 220 so the resistance is less. But it still couldn't be nichrome wire. That we've reached the limit unless I get a controller to cut the temperature well within the limit of the element. That's the only alternative there. But for full throttle, maybe that molybdenum element could handle full throttle for 6 hours, because that's what we're trying to do. We're trying to dump as much excess energy into the sand as we can in the like 6 hour window, 4 to 6 hour, depending on the time of year, for the excess solar, so it can heat the house is what it was for in the wintertime. We don't want to go slow is what I'm trying to get at. Trying to go slow enough to save this element, then you'd have to have something freestanding built, just like concrete benches or something else in your house with maybe aluminum ductwork where you can blow air through it, kind of deal. To use this kind of an element is what I'm doing, and a controller, multiple elements, multiple controllers, so you can keep the temperature down is what I'm trying to get at. And another thing that this element, this nichrome wire might just not be able to do it, is once it saturates its temperature, then it's pretty useless. Is what I'm. You can't add much more to it. You want something that can go full throttle, or at least that's how my mind is wrapping around this project, the sand battery project. Let's go look at the top of our stove. And y'all, I can't stand for very little long, so I got to pause this, and I'll hopefully get you back on without shutting it off. All right, we did it without shutting it off. Here's the top of the Ugly Iron Man, and I'm going to try to get this in the frame. Here we go. Oh, there it is. Okay, yeah, the surface is 130-ish, within a degree or three. Let me move some of that sand, and just not even very much. Well, that didn't help very much, did it? It's still kind of climbing. When I did this temperature before, it was like about 150, not very deep. Oh, yeah, that's probably what it was. I wasn't getting in the frame where I should be. There we go, 150-ish. That's about what it was earlier, too. And I didn't mean like exactly 150. Well, it says it's 150. But I probably didn't scratch down that deep either. But it can hold temperature fine, even with a PID controller using the nichrome wire. It would be okay. Let me sit back down before I fall. Oh, and we did that successfully. Y'all didn't want to hear a fat man squirmer trying to get up and down. That's why I was pausing it. It takes quite a bit for me to do that anymore. That solar rack out yonder, that almost killed me dead. That was literally all I could do. And even then, I had to wait a couple days to figure out some of them little tricks in the puzzle. But like it is, if this wasn't the Ugly Iron Man and it was just another concrete container filled with sand, or like an aluminum container filled with sand or something like that, where it's going to give off the heat, these would work. How to say, they would be cheesy, and you would definitely have to have like multiple controllers to make it work. But you could make it work, is what I'm trying to get at. I'm thinking a better element, a more robust element, would be the answer with a controller. Always with the controller. Today I just tested it to see when it was going to fail. That's really what it came down to. Today was just one of them, So, and that's where it failed, about 4 hours in. And had it been cycled at all or kept at a lower temperature, I'm sure it would have burned for weeks or months. But it's August, so if it fails in 3 hours in August, no harm, no foul. If it fails 3 hours in January, well, that's a problem when you're relying on it. So I was just trying to work out the kinks, cheapest way I could. Started with the cheapest wire, cheapest element, and I'll go up from there. But seeing what this one did in 4 hours, I would never use the element for much more than 6 hours in the day, ever. So whether that's summer, winter, whatever, winter you'd probably use a little longer off the batteries. But everything was functioning fine. I had plenty of power. The inverters were doing it. Everything was working, except I think we exceeded the working capacity of the element, where it just saturated the heat and it killed it. I'll know again when I dig it up, and I'll see if the wire broke somewhere, see if there's a crack in the element, whatever. I don't see it failing any other place is what I'm trying to get at. So, and the circuit's still alive. It was glowing. The LED was still glowing on it. So it's not that. Okay, guys, I'll let you go. That was just the update on the sand battery and the limits of these cheap elements. And any of these that have the nichrome wire is going to be the same. It's the wire that limits the element, not anything else. And whether it's the heating element in the bottom of your oven or the heating element in the hot water tank, whatever. And I already knew about the heating elements in the hot water tank. Those can die prematurely if they're not surrounded by water. They can't even heat up. Like the saturation temperature will wreck those quite easy. And what I put this thing through today was a torture test. I could have backed it off and kept it at no more than like 500 degrees. And because first click, I wish I could add pictures to this, but I can't. First click, it went overheat. But I got one picture that said like 9 something, and the next picture was for OH for overheat. And but I saw the last time I saw it read, it was like 1,021, and then that was it. It just croaked, and it was well over. I mean, it got to that. It ramped up so very fast. It was well over that temperature. Is what I'm trying to get at. And I just think we've reached the saturation for the nichrome wire without a controller. I got to keep saying that, without a controller. With a controller, you'd have been able to fluctuate it, because it's a feedback loop where it's gonna ramp the element. It's made for this. That's what the device is made for. But with the right element, I think it'll work a lot better. Okay, now we're done rambling. We're gonna talk to you later, and it was good. It was fun. I hated that it didn't work better than it did, but I figured at some point it was going to fail, whether it was hours or days or whatever. It wasn't going to last, is what I'm trying to get at, especially not without a controller. And I do have the little controllers that I use for heating the water are PID controllers. So it's not like I don't have them. I just deliberately didn't use one. That's the difference. But I don't have any with like high temperature probes. All mine are low temperature probes. I'd have to sleeve the probe that I have in something like that to make it work. But they make them $12-15 for the probe. Same 2 wires. You just change the end of the probe out, and it'll go from like low temperature PID to a high temperature PID. Same thing. As long as you got the digits ahead of the decimal point. And some are programmable where you can move the decimal point and all that. Don't buy cheap. If you're going to duplicate any of this, buy a quality PID. That's what you want. Proportional, integral device. I don't know. Proportional integral is what it's a loop controller. But buy something quality, and you'll not like waste too much money. They're not expensive, like $25-50 for the controller. The element that I'm talking about, probably $170-200 for the next grade up from. Well, there's a few grades in between, but there's no real way. There's no real reason to mess with anything price wise. You just jump to the top. It's fine. All right. Well, we'll talk to you then, and hope you all having a great day, and your experiments and your stuff is going good. All right, talk to you then.